About to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out.
Another video about the Arduino Gambit. Today we're going to have a tutorial on exactly how to build a smart house project I've made, and even the schematic diagrams and the program will be included in the description down below. So make sure to stay tuned for more to understand how all this project works and how each component plays a role in the whole project. Enjoy! Generally, once two consecutive pitches are detected within a time frame of 300 milliseconds, the light state switches or is turned on. Imagine your light right now is currently turned off. Eventually the state is going to be turned on. So regarding the hardware of the microphones, it's rather simple as to compare with the software. In order to measure the pitches, we integrate a simple microphone in which I have chose to integrate it on pin 9 of the Arduino Uno. You can choose to do this project within several different Arduinos, or you could even use a single Arduino Mega as I have done. So your LED lights can be located on pin 13 and the ground. The fan concept consists of a temperature sensor as well as a USB fan that will only be activated when the temperature sensor measures a total of 30 degrees in Celsius, which is interchangeable in the program. Note that the temperature sensor I used was the Dallas temperature sensor, whereas the DHT11 sensor is more commonly used, and it's just a matter of choice. Both are effective. Make sure to check out the link in the description below for the program. The program I used combines two programs, which are the temperature sensor as well as the microphone declapping sensor. So we first have a detection range, the status of the microphone, which in default is high but switches to low when there is a signal or a double clap. And of course you have the status of the lights integrated in a boolean value. And program setup, we simply set the default baud to see our ping results, and also the starting point of the LCD screen, which is the 16x2 LCD. In our loop function, we call a function called the microphone check, and it will simply measure if the number of claps within the 300 millisecond time range is true. And the very next step of the loop function, we constantly confirm the average room temperature to see if it is 30 degrees and even beyond in order to activate the fan. Now the final concept we elaborate on is the Peltier concept. For the Peltier, we first have a power supply which is in total 220 volts, and eventually this 220 volts is going to be divided into different wires, and 12 volts is going to be focused into the fan, which will focus and converge heat into a single side of the Peltier material, and on the other side we have a cold surface. This cold surface will cause air particles to be condensed, and eventually you have water as a result. So overall, this project consists of different schematic diagrams, and you could even compile all of this into a single Arduino Mega, or you could even simply have it all into different Arduinos. So I hope you enjoyed this, and stay tuned for more projects like these.